Russia launched a satellite with the designation Cosmos 2576 from its Plesetsk Cosmodrome in North Russia on May 16, 2024, and its launch led to a United States response in the United Nations on May 20, 2024. According to U.S. Ambassador Robert Wood, this launch was likely a counterspace weapon capable of attacking satellites in low Earth orbit. Low Earth orbit is where most reconnaissance satellites are located, but also includes the Hubble telescope, the International Space Station, commercial imaging satellites, and the Starlink satellite constellations, to name a few. Cosmos 2576 is also in a low Earth orbit and is in the same orbital plane as the U.S. Keyhole Spy satellite designated USA 314. The Russian launch of Cosmos 2576 and others like it has significantly raised concerns that the weaponization of space is close to becoming a new reality. The Outer Space Treaty of 1967 currently has 115 countries as parties to the treaty, as well as 22 others who have signed but have not received final government approvals in their respective countries. The US and the Soviet Union signed the treaty in 1967. The Russian Federation assumed it after the dissolution of the Soviet Union in 1991, and China signed it in 1983. It forbids the deployment of nuclear weapons in Earth orbit, on the Moon or its orbit, and on any celestial body. Though not specifically designated, the parties have generally accepted and followed the idea that Earth's orbit would be free of weapons. In October 2006, President George W. Bush's administration made a significant revision to the United States national space policy. The revisions did not call for the weaponization of space, but they did state that the U.S. Air Force Space Command, now the U.S. Space Force, can take military action in space to protect U.S. space assets and deny space to a U.S. adversary. This includes ground-based systems that can target satellites in space, as well as orbital defense systems. The United States has been judicious in applying this new policy to avoid a space arms race, but it did open the door for the U.S. and its adversaries to explore weapon options. Both the U.S. and the Soviet Union had explored orbital and ground-based weapon systems to attack targets prior to 2006. The United States developed and tested the ASM-135 ASAT anti-satellite missile in the 1980s, which an F-15 Eagle fighter jet would carry and launch. In September 1985, the United States conducted the first successful use of this weapon against the U.S. Solwind P-78-1 solar observatory at an orbit of 345 miles, or 555 kilometers above the Earth. The United States destroyed the satellite before the congressional ban on U.S. anti-satellite weapons took effect in October 1985. The Soviet Union also had an anti-satellite program that started work in the late 1960s and had a successful intercept of a test satellite in 1968. But the system was considered experimental and did not form into a weapon system on top of an ICBM until the early 1970s. The Soviet Union conducted tests on this system from 1978 to 1982, and the weapon system was decommissioned in 1993. The Bush administration's 2006 decision was based on the United States becoming more dominant in space and launching more and more capable satellites. These satellites had civilian applications, but more importantly to the administration, they had military applications and would need to be protected. At the time, the United States was considered the only global power, and its military had a global reach. In this global reach, U.S. military capabilities were heavily reliant on the use of its satellite assets for not only intelligence and accurate targeting, but also communication. The current concern is that the U.S. space assets did not assume weaponization of space and are therefore potentially vulnerable to attack. The Cosmos 2576 flight is not the first of its kind, and the United States and China are considered to have performed similar missions against other countries' satellites. What is becoming concerning for the U.S. is that Russia, largely limited to being a continental power, is not as reliant on space-based systems as the U.S., nor is it capable of projecting force globally beyond its strategic nuclear weapons. This means that the U.S. systems in space are vulnerable to Russian attack and would go a long way in leveling the playing field by greatly reducing American military capabilities that are so reliant on space-based systems. Cosmos 2576 is not considered a global threat because it can only attack one satellite, USA 314, in its orbital plane. This is concerning, but not crippling, as the Russians are developing the capability to deploy nuclear-armed satellites in space. These satellites do not have to stay within a U.S. satellite's orbital plane, but instead assume positions at various altitudes in Earth orbits. We refer to these as indiscriminate counterspace weapons because they don't specifically target a particular satellite. If the Russians decide to deploy such satellite nuclear weapons, they can keep them in orbit until a geopolitical situation arises and the Russians decide to use them. The nuclear weapons on these satellites aim solely at satellites, not at earthly targets. The nuclear blast can be effective in kinetically destroying satellites, but it is the non-kinetic use that is more concerning. The nuclear explosion can destroy satellite optics, but most concerning is the electromagnetic pulse, or EMP, that would destroy the electronics of any satellite within range, thus rendering them useless. The kinetic and non-kinetic effects would vary depending on the size of the nuclear warhead. As previously mentioned, the U.S. developed a satellite system that did not anticipate its inclusion in a weaponized space, rendering it susceptible to such an attack. Although some satellites have additional protection against solar activities that can disrupt electronics, it is unlikely that these can withstand an EMP attack unless they are at the edge of the EMP effective range. Since they rely less on satellites for their military and civilian applications, the impact of this indiscriminate Russian weapon on their military operations would not be as significant. Also, since their military routinely trains with systems that have less satellite reliance when compared to the U.S., their forces would become relatively more effective than the U.S. forces, which would have to readjust to non-satellite-based systems. This is what's raising concerns in the United States about Russia's increasing boldness in weaponizing space. The deployment of non-discriminate nuclear-armed satellites would be against the Outer Space Treaty, but the U.S. has little else it can do to punish the Russians and dissuade them. This is due to the Ukraine war and the diplomatic isolation of Russia, and the sanction programs against it have used about all the types of economic sanctions available to the West outside of cutting off Russian oil from the world market. If the United States cannot dissuade Russia, it must pursue the costly option of bolstering passive defensive measures of U.S. space assets and/or creating active defense systems against potential attacks, such as satellite intercept weapons. A potential space arms race could commence, involving China and most likely India. The United States could use one diplomatic lever to incentivize China to restrain Russia from pursuing indiscriminate space-based weapons. The envisioned Chinese military capability as a leading military power mirrors the U.S. system and is, therefore, reliant on a space-based system. The Chinese also built their system largely on the U.S. assumption of non-weaponization of space. If the Russians launch indiscriminate nuclear attacks in Earth orbit, it will significantly impact both the Chinese and U.S. capabilities. The Chinese strategy to eventually project power in the first and second island chains in the Western Pacific Ocean means that it will not be a continentally limited power like the Russians. India, being a member of the BRICS and a significant buyer of Russian oil, could potentially exert pressure on Russia. The not-so-talked-about issue is all the debris that such an indiscriminate attack would create, especially in low Earth orbit. The debris created by destroyed satellites and the loss of attitude control on satellites, not kinetically damaged, have a great potential of creating so much space debris for years that no satellites could safely operate in low Earth orbit due to the risk of debris strikes destroying new satellites, which would create more debris. It would potentially take years for enough debris to deorbit and burn up in the Earth's atmosphere before low Earth orbit could be safe for use. Also, depending on the amount of debris, rocket launches may not be able to make it to medium or high Earth orbit because they cannot safely travel through low Earth orbit. It is doubtful if the Russians would pursue such a course as part of their threatened retaliation against the West for their continued support of Ukraine against the Russian invasion. If war did come between the West and Russia, it would most certainly be used if Russia was able to fully develop the system. However, simply parking satellites in Earth orbit with the option of detonating them at some point in the future is well within Russia's technology, as they perfected the use of nuclear warheads and satellite operations as early as the 1960s. The Russians could decide to deploy the capability as retaliation and hold the world's satellites hostage to a Russian attack if it is provoked, and China and the U.S. could not do anything about it in the near term until they developed the ability to precision strike the Russian satellites simultaneously. Of course, this would lead the Russians to deploy more satellites to counter the capability. Thus, a space-based arms race will begin,